We continue with polynomials, and mainly with operations on polynomials. I mean addition, subtraction, multiplication, and in the next video, division as well. So how to add or subtract polynomials? Well, there are two conditions to add terms in a polynomial. What are these two conditions? First of all, they must have the same variable. Second, they must have the same exponent. As an example, if I have 3x to the power of 2 and 8x to the power of 2, can I add these two terms? Let's see. What is the first variable? It is x. And the second variable is x as well, so the first condition is satisfied. What about the exponents? The first and the second exponents are 2, so again the second condition is fulfilled, which means I can add these two terms. But how do I add? It means that I have to add the coefficients of these two terms, which means 3 and 8. So 3 plus 8 is 11. Do I add exponents? No, I never touch the exponent. So the exponent remains as is, it remains as 2. We're not multiplying here, we are adding. So to add two terms, I only add the corresponding coefficients of these two terms. What if I have 6x to the power of 4 plus 8x? Let's see, do we have the same variable? Yes, we do. Both are x's. Do we have the same exponents? No, we don't. The first exponent is 4, and the second exponent is 1. So both exponents do not match. This means that I cannot add, and that's it. I just leave them as they are. 6x to the power 4 plus 8x, nothing changes. What if I have something like 5x squared plus 3t squared? Again, I cannot add. Why? Because the variables are different. Here I have x, here I have t, so we cannot add these two terms. So that's it. Of course, anything that works on addition also works for subtraction. They are the same. Let's now do these two examples. In the first example, I have this polynomial added to that polynomial. Step number 1, let us get rid of the parentheses. So first, I just safely remove the parentheses. There is no minus here. There is no minus. There is nothing. So I just copy paste all the terms with no change, but just with the parentheses removed. What about the second polynomial? Well, I have a plus, and if I distribute the plus, if I multiply the plus by all the signs, plus times any sign doesn't change the sign. So plus times plus is plus, plus times minus is minus, which means I again remove the parentheses with no change. All right, we now look for the like terms. So if there are any like terms, we add corresponding coefficients as I mentioned earlier. So let's see. Let us start with 3x to the power of 5. Any like term? Any other x to the power of 5? No. So I simply copy it. So 3x to the power of 5 is copied, and I just scratch it to make sure that I do not miss any other term. What about x to the power of 4? For x to the power of 4, I have negative 2x to the power of 4 and 9x to the power of 4. Okay, so I have same exponent, same variable, which means I simply add. So negative 2 plus 9 is positive 7, x to the power of 4. Let us scratch the terms. Let's move on to x to the power of 3. So I only have one term which has x to the power of 3, so I just copy it. So plus 7, x to the power of 3. X to the power of 2. So we have negative x to the power of 2, which means negative 1x to the power of 2, and positive 10x to the power of 2. So negative 1 plus 10, that is a positive 9x to the power of 2. What about x? We have positive 5x, negative 8x, so positive 5 minus 8, that is a negative 3x. And finally, for the constant terms, we have negative 1 and positive 3, which is equal to positive 2, and this is the final answer. Same for the second expression. So here I'm adding and subtracting three different polynomials. Okay, let's repeat the same scenario. So first, for the first polynomial, there is no sign, so I just, outside the polynomial, so I just remove the parentheses safely, x squared plus x minus 3. For the second polynomial, I have this minus, which means I have to distribute the minus over all the terms. And whenever minus is multiplied by any other sign, the sign flips. So if it is plus, becomes minus, and vice versa. Which means I remove the parentheses and change all the signs inside. So negative 3x to the power of 3 minus 10x to the power of 2 plus x becomes negative x, and plus 7 becomes negative 7. Next we have a plus, and the plus will not change anything inside, so I remove the parentheses with no further change. All right, we now look for like terms and add them, if any. So we start. Let's start with the highest exponent, so negative 3x to the power of 3, that's the only x cubed in this expression. So minus 3x to the power of 3. I like to scratch the terms. You don't have to do that, but I just prefer to do that just to make sure, just in case, so that I do not miss any term. We have positive x squared and negative 10x to the power of 2. That is a negative 9x to the power of 2. We have positive x, negative x. Well, positive x and negative x just cancel out. So I am left with positive 4x. Finally, for the constant terms, we have negative 7 and minus 3. That is a negative 10. All right, we move on to multiplying polynomials. How do I multiply two polynomials? Well, there is no condition for multiplication as we had in addition and subtraction. Any two terms, literally just any two terms, can be simply multiplied. But I mean, how do I multiply two terms? Well, let me show you. If I have something like 10x to the power of 5, that's the first term, or if you will, the first monomial, multiplied by 6x to the power of 3. To multiply two terms, I first have to multiply the coefficients. So 10 times 6 is 60, and I add the exponents of the variables. Why do I add the exponents of the variables? Well, because I am multiplying x to the power of 5 and x to the power of 3, so both have the same base. Multiplying two numbers with the same base means that I have to add the corresponding exponents. So it simply is x to the power of 8, which is 5 plus 3. So this is how I multiply two terms. Let's now do a couple of examples. In the first example, I have x to the power of 3 multiplied by the other factor. When I multiply, I have to distribute x to the power of 3 over the entire polynomial, the entire next polynomial. I mean, I have to multiply it by every single term in this polynomial. So it becomes x to the power of 3 times 4x squared. When I have x to the power of 3, it's like 1x to the power of 3. So I multiply the coefficient by the coefficient, as I said, and I add the exponents. So 1 times 4 is 4. And x to the power of 3 times x to the power of 2 is x to the power of 3 plus 2, that is 5. Let's continue. I also multiply the signs. So here I have a plus. So plus actually doesn't change anything, but I always should make sure that if in case I have a minus, I have to change the signs inside. So minus 1 times 7 is 7. And x to the power of 3 times x, which is x to the power of 1, that is x to the power of 4. Finally, plus times plus is plus. 1 times 3 is 3. And x to the power of 3 times, there is nothing here, or simply x to the power of 0. So it becomes x to the 3 plus 0, which is x to the power of 3. And that's the final answer. Of course, just in case, when I multiply, I also have to make sure if I have any like terms so I can add them in order to express the answer in its simplest form. In the next example, we have two polynomials. So I have to distribute one of the polynomials or one of the factors on the other. So x squared, I have to multiply it by the first, second, and the third term, as well as 3. I also multiply it by all the other terms. So we repeat the same process, but I have to multiply every single term in the first polynomial by all the terms in the second polynomial. So x squared times 2x cubed means that this is 1x squared. So again, 1 times 2, that is 2. And x squared times x cubed becomes x to the power of 2 plus 3, that is 5. Then 1x squared plus 6x, that is 1 times 6 is 6, and x to the power of 2 times x to the power of 1 becomes x to the power of 3. 1x squared times negative 1, that is a negative x squared. We are done with the x squared. Let's move on with the 3. So 3 times 2x cubed, I just multiply 3 by 2. There is no x in front of the 3, so it's just 6x to the power of 3 plus 3 times 6, that is 18x, and 3 times negative 1 is minus 3. We move on to the second step, where we have to check whether there are any like terms to add. We start with 2x to the power of 5. That's the only term which has x to the power of 5, so I copy it. Then I move on to x to the power of 3. We have 1 and 2 terms, so that is 6x cubed plus 6x cubed, that is a 12x to the power of 3. Then any x squared? Yes, there is. There is 1x squared, so that is a negative x to the power of 2, as well as one term with x, that is a positive 18x and negative 3, and that's the final answer. I would like to do one more example where I have 3 factors multiplied by each other. I'm not just doing this third example just as a repetition. I just want to point out a common mistake. Many students usually do this mistake. What is this mistake? Well, let me first of all give an example using numbers. Let's say you have 2 times 3, let's say times 5. How do I multiply these numbers? Well, I multiply 2 times 3 becomes 6, and 6 times 5 becomes 30. So the answer is simply 30. In other words, I multiply the first 2 terms, and the answer I multiply it by the third term. However, I do not do this. I cannot say 2 times 3 times 5 is 2 times 3 is 6, and 2 times 5 is 10, and then I say 6 times 10 is 60, right? So I cannot distribute the 2 over the terms. We're not doing multiplication of polynomials here, right? We're not distributing here. We cannot distribute. I just multiply the first term by the second and the answer by the third. So this is wrong, and this is the good version of the solution. Similarly, if I have these 3 terms here, I cannot say x times this and then x times that. That's wrong. Because again, I'm multiplying the first factor by the second factor by the third factor as the 2 times 3 times 5. So what do I do then? Well, I just distribute x over one of the factors, let's say this, and then the answer I distributed over the third factor. So I distribute x over 3x minus 1, that becomes 3x to the power of 2, and x times negative 1 is negative x. What about 2x plus 5? I just copy it for now. You see? So I just distributed x over one of the terms, and then I do the actual multiplication as we did in the previous examples. Can I multiply, for example, x by 2x plus 5? And then distribute it over 3x minus 1? Yeah, of course. As long as you do not multiply the x by both factors, that's good. In short, I multiplied by one of the factors, and then the answer I multiplied by the second factor. So now 3x to the power of 3 times 2x, that is a 6x to the power of 3, 3x to the power of 2. Now 3x to the power of 2 times 2x is 6x to the power of 3, 3x squared times 5, that is 15x squared. Then negative 1x times 2x, that's a negative 2x to the power of 2. And finally, negative x times 5, that is a negative 5x. Then we add like terms, if any. So we have 6x to the power of 3, that's the only x cubed in the expression. We have 15x squared and negative 2x squared, that is a 13x to the power of 2. And finally, the negative 5x. And that's how we simply multiply any two polynomials. In the next video, I will talk about division.